All right, so if you finished the series circuit problems, which look like this, all right, then you should be moving on to the series circuit homework, which looks like this. So this is a solution video for that problem, and this one is actually a little bit hard. So if you need this video, I am not surprised. They're a little bit tricky, so I wanted to give you guys the solutions here so you could see what was going on and make sure you knew how to do it. So I'm going to go through that problem set in this video here. This will be my last one for the day. If you finish with this, you're finished. So let's share that. Here it is. Mine might look a little bit different yours than because I had to draw it twice. I accidentally erased all my edits the first time. So it might look a little bit different. I tried to make them look as same as possible, but we're essentially doing pretty much the same thing that we did with the series practice problems worksheet, the first one, right? We're using kind of a combination of what we learned about series circuits and Ohm's law to go ahead and solve some of these things. So I'm going to write Ohm's law up at the top. It's three versions: V equals I times R, I equals V divided by R, and R equals V divided by I. Right? Those are my three versions of Ohm's law. So we're definitely going to use those. And we're also going to use the three things that we know about circuits, series circuits. One, that current is the same everywhere. Everywhere. Two, resistance. Actually, I should say component resistances add to the total resistance. So component resistances adds to total resistance. And three, that the component voltages add to the battery voltage. Add to battery voltage. And in each one of these problems, I've asked you guys to find a specific thing, right? Find the current in the circuit and the voltage used by each of the resistors. But I kind of want to just fill in all of this stuff, right? Let's see if we can figure out everything that we could possibly figure out about these circuits. And I think that's really the easiest way to go about these types of problems. I know you're doing these on your own. I'm not there to kind of show you how to do it, but hopefully this makes an okay substitute. So three resistors connected in series. I drew that out for you, right? R1, R2, R3. Those are my three light bulbs connected in series. One has a resistance of 10, one has a resistance of 30, and one has a resistance of 60. And they are connected to a 12-volt battery. So there's a picture of what we got going on. All right, and we want to find out all this stuff about the circuit. So first thing we're going to find out is the total resistance, because that's the easiest. We know that component resistances add to the total resistance. So if I have a 10, a 30, and a 60, 10 plus 30 plus 60 is, I had to think for a second about that, 100. Total resistance is 100, right? 10 plus 30 is 40, plus 60 is 100. So we get the total resistance there. And once we have the total resistance, right, this battery voltage is total voltage, right? So the total voltage is 12. If I know total voltage and total resistance, I can find total current, because Ohm's law says that current is voltage divided by resistance. So total current is total voltage divided by total resistance. And 12 divided by 100 should give us 0.12. So I get my current, 0.12 amps. All right, so first we used this second law right here, the second part, that component resistances add to total, figured that out. Then we used Ohm's law and the fact that current is equal to total voltage divided by total resistance for the second part to figure out this. Now we're going to use the first part of series circuits, that current is equal everywhere, to say that, okay, the current through resistor 1, 0.12, current through resistor 2, 0.12, current through resistor 3, 0.12. They're all the same because current is the same everywhere. And then finding voltage becomes really easy because we use this first version of Ohm's law. V is equal to I times R, and we just have to do a little multiplication, right? So we've got our resistances right here, 10, 30, and 60. So we're going to multiply this by 10. That'll give us 1.2. We're going to multiply this by 30. That'll give us 3.6. And we'll multiply this by 60. And that'll give us 12 times 60, 7.2. We might have to double check that one, but I think I'm right. And then if we add all these up, actually the easy way to check is to add all these up and see if it gets 12. So 1.2 plus 3.6 is 4.8, and 4.8 plus 7.2 is 12. So that checks out, right? We can add these all up and they have to add to 12 because the total voltage is 12, right? So that's this third part here. Component voltages add to the battery voltage. So we can check using that one. So we used part 3 to figure out total resistance. We use this part of Ohm's law, the I equation for Ohm's law, to figure out total resistance, or sorry, total current. Then we used the first part of series circuits to say that all the currents are the same. And then we used the first version of Ohm's law, V equals I times R. We knew all the resistances. We could just multiply those through and get our voltages, right? So not anything crazy, but maybe a little bit tricky. All right, so second problem, we've got 3 resistors connected in series, 150, 300, and question mark. We don't know. So I've got my series circuit. I've got 150, 300, and not sure. I know the battery voltage is 24, so that goes right there. And I know the current running through the circuit is 0.025. So I made a note of that right here. The current through the circuit is 0.025, which really helps us fill out this table, because if I know the current here, I know all of the currents. So total current, I1, I2, I3, all the currents are 0.025. They have to be, because the current is the same everywhere. All right, so that first part of series circuits makes that really easy. We just have to fill in all those values. Total current's really, or total voltage is really easy too, because total voltage is just the battery voltage. So battery voltage is 24. That means total voltage is 24. Yep. We can use total current and total voltage to find total resistance, because the other part of Ohm's law right here, the one that we haven't used yet, resistance is equal to voltage divided by current. So resistance equals total resistance, total voltage divided by total current. Voltage we said was 24. Current we said was 0.002 or 0.025. And we just have to divide those. This I cannot do in my head. I'm going to guess like, I can't even guess. I don't even know enough to guess. 24 divided by 0.025, 960. So the total resistance is 960 ohms. 960. All right, so we used the fact that current is equal everywhere already. We used this part of Ohm's law, right? R equals V over I. So we used that to figure out R3, right? The value of this missing resistor. We can actually use the second part of Ohm law. The components add to the total resistance. Well, I just solved the total resistance. The total resistance is 960. If I know this one is 150 and this one is 300, then what's left to get, what do I need still to get to 960? Because 960 is the total. So 150 plus 300, that's 450. So to get from 450 to 960, I think I need 450 to 960, 510. Does that math check out? Minus 150 minus 300, 510. Yep, 510. So because I know that the component resistances have to add to the total, and I solved for the total already, well, all I have to do is figure out the distance. Difference. 150 plus 300 is 450. What else do I need in order to get to 960? Well, I need this to be 510. So I get my missing third resistance. And now we're just calculating voltages. I have R's and I have I's. That's the last voltage is I times R. So I can multiply this by 150, multiply this by 300, and multiply this by 510, right? So I times R, I times R, I times R. And if I go ahead and do that, I can get all my voltages. So 0.025 times 150 is 3.75. 0.025 times 300 is just going to be twice that, 7.5. And 0.025 times 510 is 12.75. And if I add all these up, I have to get to 24. So 12.75 plus 3.75 is 16.5 because 7.5 plus 7.5 is 1.5. So that'll take us from 12.5 to 12.75 to 13.5. And 13.5 plus 3 is 16.5. 16.5 plus 7.5 brings us to 24. So that checks out. We do get the correct voltage there. So first thing we used was the fact that current is the same everywhere to find all the currents. Then we used this version of Ohm's law to figure out the total resistance. Then we used the fact that resistances always add to the total resistance. 150 plus 300 plus something had to add to 960. That something has to be 510. So 150 plus 300 plus 510 adds to 960. And then once I have each of my currents and each of my resistances, all I have to do is multiply to get all my voltages. So there is number 2. And last but not least, we have 3 resistors in series. This time we know all the resistances again, 75, 25, and 50. We also know the current is 0.45, and we want to find the voltage everywhere and the voltage of the battery. So this one's probably the easiest one, if I am being honest, because total resistance, all we have to do is add up the resistances. 75 plus 25 plus 50. That's 100 plus 50, 150. Current's even easier because they give us the current, and current has to be equal everywhere. So 0.45, 0.45, 0.45. Oops. Erase. 0.45, 0.45. All right, so there's all my currents. And if I know resistances and currents, I actually haven't even done any math here, but to find voltages, we know voltage is I times R. I have all the I's, I have all the R's. So this I'm going to multiply by 75, right? That's R1. This I'm going to multiply by 25. That's R2. And this I'm going to multiply by 50 because that's R3. So I multiply those out. 0.45 times 75 is 33.75. 0.45 times 25 is 11.25. And 0.45 times 50 is 22.5. There's my 3 voltages. All right. And to get the total voltage, all I have to do is add those up. Or so 33.75 plus 11.25 plus 22.5 is 67.5 volts. And I could check that actually if I wanted to really easily, because we could use this V equals IR. This actually might even be an easier way to do it. I didn't think of this as first. I don't know why, but voltage is current divided by current times resistance. I have a resistance. I have a current. I could have just multiplied these two numbers together. 150 times 0.45 is 67.5. So I could have done that another way. I did it by adding up these voltages, but I could have just multiplied current times resistance there and got total voltage. All right. So there's everything. Again, maybe a little bit more complicated. We'll talk about this a lot more on Monday. But if you got that done, excellent. Submit it. Have a great weekend. I think I'm finished. I'll catch y'all later. Stop and stop.